Hello everyone. In this lecture, I want to discuss high order linear differential equation. So we will see the standard form of linear differential equation of high order. So this is the standard form of a linear nth order linear differential equation. So this is the highest order dny d upon dxn plus p1 less order derivative n minus 1, and then after n minus 2 so on, and into y pn into y equal to x, where p1 p2 pn are function of x capital X is also in a function of x. Okay, so this is an nth order linear. Why is linear? Because highest order, the power of highest order derivative is 1, so it is in a linear, and highest order derivative is nth order, so nth order linear differential equation. Okay, where p1 p2 and pn are function of x, may be constant and may be function of x. Okay, so if here this x equal to 0, then we can say that this differential equation is homogeneous linear differential equation. Okay, if x is not equal to 0, then we can say a non-homogeneous linear differential equation of nth order. Okay, so here I have clearly mentioned, if x equal to 0, the equation is called homogeneous linear differential equation. I have written in the short form linear differential equation. If x does not equal to 0, so then it is called non-homogeneous linear differential equation. Okay, so it is, here is x capital X. If x equal to 0, then we can say homogeneous linear differential equation. If x does not equal 0, then we can say non-homogeneous linear differential equation. Okay, so next, solution of a linear differential equation can be separated into two parts. First part is if p1 p2 pn, we can say in our standard form these p1 p2 p3 so on pn are constants. Okay, first condition is that if p1 p2 pn are constants. Second condition is p1 p2 pn are function of x. So if we want to find the solution of a linear differential equation, so it depends on two conditions. First condition is if p1 p2 pn are constants. Second condition is that if p1 p2 pn are function of x. Okay, so this, it is a nice theorem. If y1 y2 y are solution of a given differential equation yn equal to 0, so then c1 y1 plus c2 y2 is also its solution, where c1 c2 are arbitrary constant. So we will do the proof of this theorem. So we have given that y1 y2 are solution of a given differential equation, this differential equation. So then we can say that we will take a linear combination of two solution y1 y2, means c1 y1 plus c2 y2 is a linear combination of a y1 y2. So it is also in a solution of a given differential equation this. Okay, so how can we say that it is in a solution or not? So since y equal to y1 and y equal to y2 are solution of equation, differential equation means we will put this solution in a differential equation, then it will come right side part is 0. If we will put this solution, so it will satisfy this equation. Okay, so if y1 is solution of a given differential equation, so it will satisfy this equation. So we have written dn yn dx p1 plus pny equal to 0. If y2 is solution, then it is also satisfy. So we will do we will multiply equations 2 by a constant c1. We can multiply here c1 up to c1. Okay, second equation is third equation is multiply by c2 so on, c2 equal to 0. Now we will add equation after multiplying c1 by equation 2, and c2 is multiplied by equation 3, then we will do add. So it will become dn y c1 y1 plus c2 y2 plus p1 cn y1 c2 y2 and c1 y1 equal to 0. So we can say that from here that c1 y1 plus c2 y2 is a solution. We can also do We can also do different we can do fraction type, means different part. C1 is in coefficient of y1, C2 is coefficient, and same thing is that. So it is here from we can say that C1 y1 plus C2 y2 is in a solution of in a given differential equation. Okay, so this solution C1 y1 plus C2 y2 is called complementary function of a equation 1. Complementary function we can write in the short form CF. Okay, if we have an x, we first of all, we if our x equal to 0, then we can find the complementary function. Okay, if x is does not equal to 0, for the right side v equal to y equal to b any particular solution of this differential equation. Okay, d and y, let us suppose that y equal to v in a, if x does not equal to 0 in this condition, so y equal to v be a solution of this differential equation. So y equal to v we call the particular solution, then general solution of a given differential equation is ca plus pi. Pi, when we have to find the pi, if our right side of the given differential equation is does not equal to 0, means we can say that if our given differential equation is non-homogeneous linear differential equation, then we can find the pi. If our given differential equation is homogeneous, then we have to find only cf. Okay, so our general solution of any given differential equation will become y equal to ca plus pi. So in our next lecture we will see that how to find the cf and how to find pi of a given differential equation. So we have seen already that our solution will be dependent on two conditions. First condition is that if p1 p2 pn are constant, and second condition is that p1 p2 pn are function of x. So in the next lectures we will discuss about first case, if p1 p2 pn are constants, so then how can find the solution of a given linear differential equation, high order linear differential equation. Okay, so I think we should stop here. In the next lecture we will discuss